All right, we'll go ahead and get started. Thank you again for joining this webinar on laboratory safety and good laboratory practices. My name is Lauren Ellie, and I'm the technical liaison here at Cherney, and I'll be conducting the webinar today. In the room with me answering your questions is Robert Braun, our client services manager, and Nicholas Hesse, our marketing specialist. So interaction is definitely encouraged in our webinar today, so please feel free to use that Q&A to ask any questions you might have or offer comments on the subject. The session is going to be recorded for others to view later on our website. All right, so today's topics, laboratory safety, we're going to be talking about what does a successful safety program look like, basic lab safety practices, PPE, chemical and equipment risks, and SDS sheets, that's safety data sheets. We're also going to be covering good laboratory practices and going over quality management system, document and traceability, and evaluating lab space and equipment for use. So, laboratory safety. Let's jump into what a successful safety program looks like. Your goal is obviously going to be to prevent accidents from happening. And when you find out that an accident has occurred, you're going to want to deal with it quickly and efficiently. A successful safety program will perform a cause analysis to investigate why and how the incident happened and resolve any issues and communicate any changes to employees. Make sure that all your employees are informed and educated about lab safety and that they follow your procedures outlined in your safety program. 9 basic safety practices that should always be followed are going to be treating all microorganisms as potential pathogens. You're going to want to use care when handling them and treat all samples as positive. You're also going to want to make sure that you sterilize all your equipment and materials that you're going to use. Sanitize your work areas before you start work and after you're done. You'll also want to make sure that you're frequently washing your hands. Obviously, when working with pathogens, cleanliness is key. And obviously, you never want to do any pipetting by mouth, and do not eat or drink within the laboratory. And make sure that you're also not using any lab refrigerators to store food or drink. You're also going to want to make sure that you're going to label everything clearly, especially any solutions made in-house, acids, bases, even your sanitizer solution. You're going to want to make sure you have the name, the expiration date, and the date of make and the initials of the person who made it. You're also going to want to make sure that you autoclave and disinfect all waste, any Petri films, any pipette tips, any inoculating loops, anything like that, that should all go through autoclave and sterilization. And then you'll also want to make sure that you clean spills up with care and make sure, like I said, treat it as if it's positive. So those 9 tips will give you a good basic foundation for lab safety. You're also going to want to make sure that you're not eating in the lab, drinking in the lab, chewing gum, sucking on any cough drops or throat lozenges, and obviously don't apply any cosmetics in the lab. So don't put on any chapstick or anything like that. Make sure that any laboratory items that are used in the lab stay in the lab or in your lab coat pocket. Make sure you're not transferring items from the lab into your offices or taking items home with you. Keep your phone out of the lab. You want to make sure that you're not taking any pathogens home with you. And cell phones have over 25,000 bacteria per square inch, dirtier than a toilet. So you don't want to risk bringing in any other bacteria or potentially contaminating anything in the lab. So it's just best that you keep phones and personal items completely out of the lab. So standard practices for laboratory safety, you're going to want to make sure that your area is neat and organized. I don't know about anybody else, that picture below gives me a little bit of an anxiety. You've got no clean space to work. There's a banana for somebody's lunch, an open mouthwash, looks like a used glove and a PCR plate. It's just kind of a mess. So you're gonna wanna make sure that you keep everything clean and organized in its spot. Make sure that you know your work area. You're gonna wanna know where your nearest exit is, your nearest fire extinguishers. When there's a safety incident, you don't wanna panic or waste time looking for safety equipment. You should know the area that you're working in and where to reach those safety materials should you need them. Make sure that you understand chemical labels, SDSs, they were previously known as MSDSs, and make sure that you notify your supervisor of any spill, any unsafe practices. And also regarding SDSs, make sure that you and your lab techs know where to find those SDS sheets within your lab. Do you keep paper copies? Are they electronic? Just make sure that if you have a spill, people know where to locate those materials should they need to reference them for cleanup. Going over PPE for laboratory safety. Working in a lab requires the right PPE for the task at hand. So make sure you've got lab coats, eye protection, a full apron if needed, and then obviously you're gonna want some gloves. Usually we'll need non-latex disposable gloves. In some cases, gloves may be optional unless your skin is broken. So even something as small as a paper cut could potentially allow pathogens to infect you. So if you're not using gloves, make sure your hands don't have any cuts and make sure that you're definitely increasing your hand washing frequency. Going over glassware safety in the lab, you're gonna wanna make sure that you inspect all of your glassware before use. You're gonna wanna look for chips and cracks. And then you'll also wanna make sure when handling glassware that you handle it properly. You don't wanna hold a volumetric flask by the neck as pictured on the right. Those are very fragile and it's a good way to end up dropping or breaking one. You need to know what type of glassware is needed for certain chemicals and make sure that your broken glassware is disposed of in the proper containers. As far as glassware safety in the lab, I can speak to this because I've been in a couple labs where I've seen technicians swirling melted media bottles as pictured in the bottom right, and they're looking for unmelted agar chunks. So they'll hold it up to the light and swirl it. And I've seen technicians take a hot bottle of agar and hold it over their head almost to kind of hold it up to the light and see if there are any unmelted chunks of media. And that's a very unsafe practice because I've seen the bottom of those bottles break open and you would just hate to think what would happen if that had occurred to that technician. So it's also your responsibility. So if you see something unsafe, make sure you say something. Also going over autoclave risks. One of the most dangerous pieces of equipment in the lab is the autoclave. It can cause burns due to heat, but also from steam. To avoid those steam burns, the best practice is to just face away from the unit and crack open the door and slowly let the steam out. Make sure that you are careful when disposing of hot autoclaved material. Liquids can splash and burn, so use the proper PPE. Utilize gloves and aprons and face shields if need be. 2 pictures below, you could have a smaller kind of tabletop autoclave, or you could be working with that much larger unit on the right. So just make sure that you know all the safety risks associated with any autoclaves that might be in your lab. This is a list of autoclave compatible materials. So on the left side, all of that is safe to put in the autoclave. Your pipette tips, your Petri dishes, Petri films. You can sterilize media and sterilize your waste. The list on the right, however, not safe to put in an autoclave as they can create toxic byproducts. So just be careful with certain chemicals in the autoclave. Don't put any acids, bases, chlorides, sulfates, anything like that. And while we're talking about chemicals, let's go a little bit deeper into chemical safety. So every chemical that you receive from the manufacturer should arrive with a label that tells you the basics, the name of the chemical, the name and address, emergency phone number of the manufacturer. It should also tell you the hazards, the required PPE, and the recommended storage instructions. It's important to know when you're looking at safety labels, the difference between signal words. Danger is going to indicate a more severe hazard and can cause immediate serious injury or death, whereas warning is going to be a less severe hazard and cause irritation or other issues. You'll also see some special symbols used on those labels. They can help you recognize if a hazard is present. So we have explosives, where a chemical can blow up under the right conditions. Flammable, that chemical can easily burst into flames. An oxidizing chemical, which can cause other materials to burn. A compressed gas, which is a gas under pressure. This chemical can explode, rocket, or harm health if the cylinder is ruptured. We also have the corrosive. This chemical can eat away at metals or other materials, also causing serious damage to skin and eyes. Acute toxicity, the skull and crossbones up there, an exposure to this type of chemical can cause immediate and serious health problems that may be fatal. The skin corrosion, obviously that's going to be corrosive if it comes in contact with your skin. And then the exclamation mark can signify a skin irritation. The next one, the next symbol closest to that is a, sorry, one moment. It can cause severe damage and cancer-causing ailments. And then the one on the far right on the bottom row is an environmental hazard. So you'll want to make sure that you dispose of that properly. So a checklist for reading an SDS, you're going to want to identify, is it the right SDS? Is your SDS up to date? And does it match the description of the material that you're working with? You're going to want to know the hazards. Are there any of those special signifiers? Is it going to be corrosive? Is it a compressed gas? What hazards are you going to be dealing with? As far as protection, you're going to want to look out over that SDS so you know what special PPE that you need, any special handling, and you're also going to want to look on that SDS to know what you're going to do in case of a spill or an emergency. Going over chemical storage, you're going to want to make sure that different chemicals are stored properly. For example, don't store acids next to bases. Make sure chemicals are properly stored in cabinets, refrigerators, freezers, according to the SDS and chemical label storage requirements. Make sure you take the time to identify incompatible chemicals, either store them in separate rooms or far away from each other. How far you have to separate them depends on the quantities and the chemical properties. Changing over to our second topic of the day, good laboratory practices. In this section, I'm going to go over quality system management, documentation practices, procedures, records, and traceability, and evaluating lab space and lab equipment for use. So the goal of a quality management system is going to be to produce accurate, precise, and reproducible results. You'll want to have a system of traceability to monitor your samples and your data flow. Some fundamentals of quality, you're going to want to say what you do at your facility. That's going to be your written procedures, your methods of analysis, your SOPs. And then you're going to want to do what you say, which is following through and doing those procedures. And then most importantly, when it comes to audit time, you're going to want to be able to prove it. Make sure that you have excellent documentation and records for traceability. And we say here quite a lot at Cherney, if it's not documented, it did not happen. You're not going to be able to prove it to an auditor unless you have accurate documentation. So for quality assurance, you're going to want to establish procedures and then make sure you're following through with those procedures. You're going to want to document everything, maintain good records. Internal audits are a great way to see where you might have gaps in your processes or where your record keeping could be better. Make sure that you keep and store all of your original data and make sure that you have documentation of instrument calibrations. As a part of good quality system management, you're going to want to make sure that you have validated methods and procedures. Any modifications must be documented and validated. You must demonstrate the modified method and the reference materials are equivalent. Say, for instance, you're typically running a sample at a 1:10 dilution. However, you want to save on media costs and run that at a 1:4 dilution. You're going to need to perform a validation to make sure that that method works and that it's validated. All essential procedures must be written. You can't have any unwritten rules where the method says something different than what is practiced in the lab. And you're going to want to make sure that all of your standard procedures are reviewed regularly. And also make sure that the people performing the tests review the procedures to make sure that what it says in the procedures are what you're actually doing in the lab. So as far as documented procedures, obviously once you have validations completed, you're going to want to make sure that all of the lab techs know where to find those methods, those SOPs, in case they need to reference certain steps during the process. Make sure techs know not to deviate from any of those procedures and only use the most recent controlled method. Don't let lab techs, print out and keep procedures, because if you make changes, they could still be referencing an old document. Also make sure that they're not using any Post-it notes. Any documentation about the samples should be written on your bench sheet, should be written somewhere else other than a Post-it note that could get lost. All changes need to go through the quality system. They should be reviewed frequently and make sure that all techs are aware of any method changes or updates. Let's go over some good documentation practices. Documentation plays a very large role in GLPs, so make sure that all the data in the lab is recorded legibly and in ink, and record all of your data immediately. Make sure you're not using any pencils. We don't want anything that can be erased. No scribbling, no write-overs. Don't make that 5 that you wrote look like a 6. And any blanks that need to be filled in with a line, make sure you just NA it, and you're also going to want to put your date and initials. Going on with corrections, if you did make a 5 that you wanted to be a 6, make sure you draw a single line through that error. The original recording should always still be legible. Like I said, no scribbling. Put your correction next to the error and then sign in date. It's also helpful in certain times to include an explanation for the correction of the error. All right. Records and forms. Without them, we don't have any valid results. That's part of the quality fundamentals of being able to prove it come audit time. You need standardized forms. Record keeping is going to allow the lab to present data and results with the assurance that results are valid. Make sure that all your records and forms are kept neat, easily locatable, and make sure that you have a clear retention policy. And your records and forms are going to be able to help you prove traceability in an audit situation. So traceability is a chain of documentation or measurements which allows the unbroken connection from all components that collectively complete a function. So how do we maintain traceability? You're going to do that through accurate record keeping. And why is traceability important? Traceability ensures accuracy and validity of your results. Traceable items should be just about anything consumable, raw materials, anything with a lot number. You're going to want to make sure that you keep track of all of those things when you use those on samples. In audit situations, auditors will often take a result and trace back all aspects, where they'll want to look and verify your incubator temperatures were within range, your media QC passed, your equipment validation, your lot tracking, even your technician training documentation. They'll want to trace all of those items to make sure that everything checks out. Continuing with traceability, why do you want to know what was used on your samples? Well, if there was an issue with a balance that was used to weigh out a sample and it was later discovered that the scale was out of spec, you would want to know and be able to trace back which test results would have been affected. So if an auditor wants to trace a sample back, you would have traceability of the equipment used during sample prep, the incubators used to grow any sample bacteria, the temperatures, and the technician's date, time, and initials of setup and of plate reads. All supplies and chemicals and lot numbers, all of that needs to be tracked. So basically anything or anybody who comes in contact with that sample. When you want good traceability, you're going to want to make sure that you have a broad picture of everything that's happened to that sample from the time it arrived at your lab to the time that you produced results. Another important GLP is QC, otherwise known as quality control. You're going to want to make sure that you are calibrating and performing maintenance on your equipment. And obviously you'll want to have that documentation to prove it. You'll want to perform and record media QC. You'll also want quality control of supplies that come into your lab and a good environmental monitoring program to ensure quality results and no contamination of customer samples. So let's talk more about the media QC. Media is a critical part of processing samples. Obviously, you can't have accurate recovery and accurate results without it. So you need to make sure that it's prepared correctly when doing so in-house. Make sure that all media prepared is stored correctly and that the media QC is tested prior to use on customer samples so you can make sure that the media performs the way it should be. Make sure that you're avoiding overheating, make sure that you're properly mixing all your media, make sure that you check the pH before you use it. All of those things come into play when you're talking about quality control of your media. Quality control when it comes to supplies, you want to make sure that you look for any damage upon receiving items. Look for any damage, defects, make sure that you review the packing slip for lot numbers and quantity. Make sure that you document your receive date and store it appropriately. Pay attention to if the inventory requires a specific temperature range to be stored at, if it needs to be kept out of direct light or anything like that. For inventory control, you want to make sure to utilize a first in, first out basis. You should use items with the oldest receive date first. And that's done just to make sure that you're using it up before the expiration date. So you're going to want to open your document your open date, and expiration date if applicable. Document for traceability your lot number when you started using the new lot, when you ended using the previous lot. And you're going to want to monitor your inventory levels for excess. You don't want to have too much inventory on hand where you're going to risk not using it up before it expires. But in that same way, you don't want to have a situation where you got to rush ship samples there. So you want to make sure that you have enough inventory on hand for the testing that you're going to be doing. On received items, you want to make sure that you have a certificate review to prove sterility, and that any proper QC was completed before it was received by the lab. Before you use it on any customer samples, you just want to make sure that everything is in line, your inventory is sterile, and that the proper QC cert was received. So far, we've talked about GLPs and quality assurance for sample setup, talked about media QC and inventory, et cetera. Let's talk a little bit about maintaining lab equipment. You're going to want to make sure that you document your cleaning schedules for any lab equipment, your balances, your pipettes, your thermometers, incubators, fridges, freezers, glassware. We're also going to go over a little bit of labware sterilization and cleaning. So first and foremost, you're going to want to keep your equipment clean. Have SOPs detailing what to clean, how to clean it, and the frequency of cleaning. And obviously you want to have that documentation of cleaning for traceability. Make sure that you're doing enough cleaning by looking into environmental monitoring, making sure that the cleaning that you are doing is effective. When you're using balances in the lab, you'll want to make sure that it has the proper sensitivity. You use certified weights to verify it. You are verifying it frequently enough, and you have accurate balance check records. Another thing to keep in mind with balances is you want the appropriate laboratory environmental conditions. What I'm talking about here is temperature and humidity. And both of those things can come into play with balances. Your relative humidity should be maintained at between 40 and 60%. Your temperature stability shouldn't vary more than plus or minus 1 degree Celsius in a 24-hour period. Those are just the most general recommended limits provided by most balance manufacturers. So just make sure that when you're using them, you keep in mind that you need to monitor your environmental condition within the lab. Thermometers, you're going to want to make sure that your thermometers are accurately checked before you start using them, and then you're going to want to check them at least annually. So make sure that you check the thermometer at the temperature that it's going to be used at. So if you're going to be using it at 55 Celsius, make sure that you check it at that temperature range and not at, say, 35 Celsius. And make sure that your thermometer is compared to an NIST traceable thermometer. Oh, one more thing on thermometers. Just good practice when you're reading thermometers, you should hold them at eye level. And if your verified thermometer has a correction factor, make sure to adjust the temperature reading before recording it. Going on to pipettes, you can have glass pipettes, you can have plastic pipettes, manual bulb pipetting or mechanical pipetters. Make sure whatever pipettes you're using that you are calibrating them, you're verifying them, and obviously having all that documentation to back that up. I've got some pictures on the bottom here Just make sure that you know your measurement of uncertainty and the accuracy of the pipette you're using. So for instance, on the left, that bulb transfer pipette is going to have a greater measurement of uncertainty than, say, the mechanical pipette on the far right side. So just make sure you keep that in mind as well. And of course, there's no pipetting by mouth allowed in the lab. Glassware, just to reiterate from earlier, you're going to want to make sure that it's free of scratches, chips, cracks, bubbles, any defects in the glass. You're going to want to make sure that you get rid of that and don't use it. Handle it properly, don't hold it by its neck, and make sure that you know what type of glassware is needed for certain chemicals. And then dispose of any broken glass in the proper container. Also, while we're talking about glassware, it's good to talk about the graduated cylinders. There is a difference between to deliver and to contain. On that picture there, you'll see on the left, underneath Pyrex, it says TC, which means to contain a certain volume, versus the one on the right, which means it's designed to deliver a certain volume. So make sure you're using the right one that fits your needs. And you want to make sure that you verified that the volume is correct. As far as incubators, you're going to want to make sure that the incubator can hold a tight range. Whatever your method specifies, you want to make sure that it's capable of maintaining that strict temperature limit specified in your methods. Whenever you get a new incubator in the lab, you're going to want to assess it for water loss and temperature mapping. So what I'm talking about there is water loss. You want to make sure that the plates that you put in the incubator aren't going to dry out. When they dry out, they're difficult to read. The bacteria won't grow properly. So you're going to want to make sure that you look into water loss as well as the temperature mapping. Temperature mapping is just to make sure that the temperature is the same throughout the entire incubator, so that the thermometer on the top shelf is going to read the same as the thermometer on the bottom shelf, and you have a consistent temperature throughout. And make sure that you are documenting your temperature checks. For incubators, refrigerators, and freezers used within the lab, it's recommended that you record temperatures twice daily. Utilize 2 thermometers per incubator or refrigerator or freezer, top and a bottom. And you can increase the amount of thermometers based on the size and space of your incubator. Make sure that your incubators have sufficient space and airflow, and your moisture loss should not exceed 15% after 48 hours at 32 degrees C. And it's a good idea just to check that quarterly to make sure, like I said, that you're not dealing with any water loss that's going to dry out your plates. Labware, sterilization, and cleaning. When cleaning labware, you're going to want to make sure, obviously, that any microorganisms are killed via autoclave. So you're going to want to make sure that those, all your labware is sterile by making sure it's autoclaved at the appropriate temperature for the appropriate amount of time. Typically, it's recommended that it maintains 121 degrees Celsius for at least 15 minutes. As far as residue on your labware, you're going to want to make sure that there aren't any antimicrobial compounds, no detergents that could inhibit growth. And you're also going to want to make sure that you use glass labware whenever possible. I know there are some plastic options, but DNA can adhere to plastic, especially over time with use where you've got scratches. It's just not easy to keep clean. Some items to consider with lab setup. You're going to want to make sure your lab is well ventilated. Ideal temperatures are going to be between 16 and 37 Celsius. Obviously, you're going to want adequate lighting for reading and interpret samples. You're going to want to make sure you have a good workspace that's able to be sanitized. No nooks, no crannies, no corrosion. You don't want any bacterial niches to form. You want to make sure that everything is able to be sanitized. In your lab, you're going to want to identify any risk areas. Obviously, pre-enrichment is going to have a low microbial load risk versus post-enrichment when that bacteria is at its happiest. You're going to have a high microbial load. So make sure that you're setting up your internal environmental monitoring program based on your risk areas. You're going to want to create a workflow that makes sense throughout your lab. You don't want to do a lot of back and forth. So create a workflow that makes sense to each separate area. Dedicate it based on what specific activities you're going to be performing in that area. And make sure you have separate equipment for areas as needed. You want to have your supplies and equipment at point of use. Like I said, you don't want to be running all over the lab. Make sure you have those supplies ready and in the best spot to be able to use them when you need them. Make sure that you have access to hand washing stations, lots of sanitizer. Make sure you have the proper environmental conditions, and make sure that you have accurate cleaning practices when entering and exiting the lab. Your lab should have limited and restricted access. Not everybody should just be able to wander in. Make sure you also have proper hand washing technique. Teach all your technicians about the risks and how to properly wash your hands. Too often we're in a rush. We just need to make sure that we're still following all those good laboratory practices and taking the time for proper hand washing and to put on your appropriate PPE. Make sure there's no eating, no drinking, no food storage within the lab, and make sure that you have proper cleaning practices, proper SOPs that demonstrate how to clean your work surfaces effectively. Items decontaminated prior to removal from the lab. Don't be taking your cell phone in and out like I mentioned earlier. You don't want to introduce any contaminants, and you don't want to take any pathogens home with you. And that's all I had. I want to thank you guys again for joining us today. If you have any questions about lab safety or GLPs, make sure that you contact me. I have my email and my phone number listed there. And make sure that you sign up for our next webinar. The next one is aseptic technique, which goes over proper sampling, weighing, pipetting, and plating techniques. And it'll also go over how to generate final results. So that's going to be a really good webinar for lab techs and lab supervisors. It'll be on October 28th at 10 a.m. And then the following webinar will be about Petrifilm in use on November 18th. So make sure that you put those on your calendars and sign up for those.